So now we're going to discuss part 2 of our review, and that is about logarithms. Alright, so the first thing to know is about common logarithm versus natural logarithm. So for common logarithm, it is usually expressed as log of 10 of x, while in natural logarithm we use log of e of x. In log of 10 of x, it is expressed in exponential expression as 10 raised to x is equal to y, while for natural logarithm we have e raised to x is equal to y. In this lesson, we're going to use the natural logarithm. Okay, and always remember that e for Euler can be cancelled out using ln. So when you write ln or ln of e, it will be cancelled out, and what is left is 1. So if you have e raised to t, to get the value of t, we just write ln of e raised to t, and it will become 1 times t, because ln of e raised to t will also give us t ln of e. So ln of e is equal to 1, therefore we are left with t. So any variable will do as a substitute for the exponent. Okay? Alright, so let's start with question number 1. So problem number 1, we need to identify the parts of the logarithm. Number 1, if e raised to 24.9 is also equal to 6.51, 52, 72, 72 times 10 raised to 10, then we use the logarithm of a b is equal to x, or also known as log of e of b is equal to x, where your Euler raised to x is equal to b. What is the value of a? What is b? And what is the value of x? Okay, so that's the first question. So for this number, we need to identify each value. Alright. So since we express log of a as log of b, we can tell that a is also equal to e. So if you're looking for the value of a, that is also equivalent to the value of e. Now for letter b, log of a is equal to b is equal to log of a of b is equal to x, and that also equivalent to e of x is equal to b, or e raised to x is equal to b. Now, as you check, we have here the Euler raised to the exponent is equivalent to a specific number. So the Euler is already a, and the exponent is 24.9. That is also equal to x. So we write 24.9 as your exponent, while your b here would be the right side of the equation, and that is 6.51, 52, 72, 72 times 10 raised to 10. Okay, so that's how are you going to identify each part. Let's proceed to question number 2. So, okay, for question number 2, we are given with a word problem. Let the function of p of t is equivalent to 8,000 times 1.01 raised to t be the population of a town in t years after the year 2000. So this is a function that we're going to use to solve for the future population of a specific town. Question. So this is our task. Estimate in which year the population will reach 8,493. Okay. So what we need to consider is the function. So the function is given. We're looking for the year in t years after 2000, and the population growth will be 8,493. So we're just going to substitute the given function, the given values to specific function. So the value for function of p of t is 8,493 on the left. That is equivalent to 8,000 times 1.01 raised to exponent t in years. Okay? So, what we need to do is to cancel out the exponent just beside the Euler, because what we need to do to get t is to remove any unnecessary number or variable beside it. Okay? So, we need to cancel out 8,000. So, we need to divide both sides by 8,000. On the left, 8,493 divided by 8,000, that is equivalent to 1.061625. 1.061625. On the right, we're just going to cancel out 8,000. So we are left with 1.01 raised to t. Okay, now, let's identify which is E, which is T, and which is B. So remember our expression, e raised to x is equal to b. So in this case, we have e raised to t is equal to b. Again, always remember that your exponent x here is not fixed or not constant. It can be any variable, depending on the given problem to solve. So in which case, we use letter t here. Okay? So for e, that is the one being raised by a specific exponent, and that is 1.01. Your t is unknown, while your b is your equation on the left, or your value on the left side of the equation. That is 1.061625. That is your b. Okay? So, to solve for t, we're going to substitute the values of this e, t, and b to the logarithm of e. So, that is t is equal to the log of e of b. As what we mentioned a while ago, x can also be t. So remember that the function or the expression of natural logarithm, it is log of e, b is equal to x. So for now, we're just going to use t instead. Okay? So let's have t is equivalent to log of e. So e is 1.01. So let's substitute that. Okay. So log of 1.01 of b. So that's 1.061625. Okay. Solving further, you can use your scientific calculator and other apps. So we have t is equal to approximately equal to 6 years. So since it is estimating, we consider 6 years. Alright? So are we going to stop there? The answer is no. Because the question is about what year or in which year the population will reach 8,493. So our base here is year 2000. So after year 2000, the population will go to 8,493. In what year? So we're going to set 2000 plus another 6 years, because 6 years was the answer for t. So we're just going to add it with 2000. So in year 2006, the population is 8,493. Or you can also state, in year 2006, the population will grow to 8,493. Okay. So that is your final answer. That's your final answer. Okay? So let's proceed to question number 3. So for question number 3, we have the function of p of n is equal to 1,000 e raised to p of n. If the function p of n is equal to 1,000 e raised to p of n, or pn, and the function of n is equivalent to 3.09 times 10 raised to 8, when p is equal to 7.2, the question is, show that log of e times 3.09 times 10 raised to 8 over 1,000 divided by 7.2 is also equal to n. So for question number 3, we're going to prove the logarithm of p of n. Okay? So, it seems complicated, it seems hard, but what you need to do is to identify the parts. So, that's the first step. Identify, recognize what is given. So, we are given with the function p of n is equal to 1000 e raised to p of n. Okay? We have the value of p, 7.2. And we have the value of the function n. Alright. So, we're just going to substitute the values given to the function. So, function of n would be 3.09 times 10 raised to 8. While on the right, we have 1000 e raised to pn. And p is equivalent to 7.2. So, we can take the exponent 7.2 times n. Alright, so what we do here is just to eliminate 1000. So, dividing that by 1000. So, both sides will be divided by 1000. And we're going to cancel out 1000 on the right. What is left here is 3.09 times 10 raised to 8 over 1000 is equal to e raised to 7.2n. Okay. So, now we're going to solve for the value of n using the value ln is equal to log of e. And yeah, and ln of e is also equal to 1. Okay? So, that is our basis. Alright? So, on the left, because we need to solve for e, we need to put ln of e raised to 7.2 n. On the left, since we use ln of e, we can also write ln of e or ln of 3.09 times 10 raised to 8 over 1000. Okay? So again, if you're going to use ln of e raised to any exponent, what will happen is the exponent will go down and yeah, as a coefficient, and then we have ln of e. So ln of e is also equal to 1. So we are left with 7.2n on the right side. So this one will be cancelled out. And we bring 7.2n. While ln of n is also equal to, the ln is also equal to log of e. So we can substitute log of e of 3.09 times 10 raised to 8 over 1000. Okay. So, last step. We're going to solve for the value of n. And since we have a coefficient 7.2, what we do here is to divide both sides by 7.2. To cancel out, or to eliminate, 7.2 on the right. So, that's dividing 7.2 both sides of the equation. So, we can cancel out now 7.2 on the right, and we're left with n. Now, we have log of e times 3.09 times 10 raised to 8 over 1000 over 7.2 is equal to n. So, you just prove the given logarithmic expression. Alright? So, question. Teacher, I'm confused. What am I going to do if I need to prove not log of e, rather ln of? Always remember that ln is also equivalent to log of e. And always use ln of n to cancel out any value if you need to solve for the exponent. So, if in case the question is about instead of log of e, that is ln, you just write ln times 3.09 times 10 raised to 8 over 1000 of 7.2 is equal to n. So, it's just the same. But in this case, we're looking for the log of e. That's why we use log of e, not ln. Okay? So, let's move to the next and last problem for logarithm. Okay, last problem would be, if you're going to have the following equation, solve for t. Okay. Solve for t if the given is c minus 370 is equal to 1000 e raised to t. Okay. So, we're just going to copy the left side of the equation. And on the right, what we do here is to divide both sides first by 1000. Okay. So, we have c minus 370 over 1000 equals e raised to t because 1000 will be cancelled out. Okay. So now, what are we going to do to solve for t? Always remember that ln of e will cancel out and it is also equal to 1. And if you're going to express ln of e raised to t, that will become, so your t will be moved down, that will become t ln of e. And we know that ln of e is 1, so you're left with t alone. Okay? So ln of e raised to t, since you put ln on the right side, then you're going to put ln on the left. Whatever you do to the right side of the equation will also be done to the left side of the equation. Okay? So we have ln of c minus 370 over 1000 is equal to, cancel out, so that will be t ln of e. And ln of e is 1. So you have ln of c minus 370 over 1000 is also equal to t. So you just solve for the value of t. Now, if you want to express this as logarithm, you can state that ln is also equal to log of e, right? So you can write log of e instead. So log of e, c minus 370 over 1000. Because usually we look for the log or the logarithm of specific expression. So in this case, we have log of e of c minus 370 over 1000 is equal to t. So that's how we're going to solve for the logarithm. Okay, so let's have the summary of formulas used. So again, log of e of b is also equal to x, and e raised to x is also equal to b. So that's the first. Second, log of e is also equal to ln. So you can interchange them. And to cancel out e, you need to put ln, and that is also equal to 1. And if you have any exponent, let's say for example, solve for m, and you have e raised to m, what you do is to multiply ln of e raised to m. And that will become m ln of e. So ln of e will be cancelled out, you're left with m only. Okay? Other things to remember, a is also equal to e in some terms depending on the given logarithm. You can also take other variables for x, for t, or any. So any variable will do for this kind of expression depending on the question. Okay, so that would be it for logarithms. I hope that you understood all of the concept. And just remember, don't panic whenever you see alien expressions. Just always relate that to logarithm. Relate that to these two powerful expressions. Log of e of b is equal to x, and e raised to x is always equal to b. If you want to solve for the unknown and you have e there and an exponent, just use the ln. Okay, ln of e. Yeah, always recognize what is given, substitute them to the given function. Okay, so there you have it. That's how are you going to solve for logarithms. So bye bye for now.